Hi guys, good morning. So in the last session, we have seen about the BPD filter, and we were discussing about the root guard, right? And we saw that your root guard is used to prevent what unauthorized or accidental changes of the root bridge in the STP topology. So if we discuss about root guard, first of all, this is enabled per port. Okay, on individual ports, your root guard is enabled, and it ignores any received superior BPDUs to prevent the port from becoming a root port, right? That means your designated port, your root bridge is going to have all the ports as a designated port, and those designated port it's going to prevent from becoming root ports. That means these ports here, right? These ports here, they will not become a root port. Okay, because we know that root ports are available only on the non-root bridge. So upon receipt of a superior BPDU, that means if a BPDU is received on this interface, what is going to happen? This port will be put to the root inconsistent blocking state. Okay, ceasing the forwarding and receiving data frames until superior BPDU ceases. Okay, so until the BPDU that is arriving here, that will cease, it will remain in the root inconsistent blocking state. Okay, and to configure the root guard, we have the command interface name spanning tree guard root. This is the command. Okay, so let's go and let me access the lab. We will see it practically. So we were looking at the STP. Root guard we have to see. Wipe, and we will start them. Let's take access, switch 1. Switch 2 and switch 3. So let the switches come up. So what is going to happen here? This switch will become the root bridge, and these two ports will become the designated port. These will be the root ports. This is designated, this is blocking. So we will see this. This is switch 1 here. Okay, now host name switch 1, host name switch 2, host name switch 3. Okay, now if I check show spanning tree. Okay, so extra ports are there. So what I'll do is interface range Z0 by 2 to 3 and Z1 by 0 to 3. All the extra ports I'll shut down so that we will not see the output. Okay, now if I take a look, if I say show spanning tree, so I can see the switch 1 Z0 by 0 is designated and 0 by 1 is also designated. These both the ports, they are designated ports. Switch 2, so switch 2 Z0 by will be root and Z0 by 1 will be designated. So we can see 0 by 0 is root, 0 by 1 is designated. Switch 3. So in case of switch 3, this will be root and this will be alternating. So spanning tree. Okay, so we can see Z0 by 0 is the alternating and Z0 by 1 is the root port. Now what? According to root guard, first of all, we will configure the root guard here. Okay, here we are going to configure on these two ports, we are going to configure the root guard. Okay, once I will configure the root guard, now if anybody is sending a BPDU that is having lower priority than the root bridge, so in that case, this particular port will be put to the root inconsistent blocking state. Okay, that is something we have to see. Okay, so what I'll do is I'll go on the root bridge and I'll say configure terminal interface range V0 by 0 to 1. Okay, Z0 by 0 to 1. Then I'll say spanning tree guard root. Okay, root guard is enabled. Now, if the switch 2 will send, okay, if the switch 2 will send a superior BPDU on this interface, so what I'll do on the switch 2, I'll just go and configure that this is having a lower priority. Okay, I'll configure a lower priority on the switch 2. So let's see. Configure terminal, spanning tree. Okay, then we have standard bridge. Okay, let's go to the interface. Interface gig 0/0 spanning tree. And here we have the, no, we don't want to change the port priority.
Sir, VLAN 1.
Hmm? Yeah,
VLAN 1
correct,
priority.
correct. VLAN information will be there. So let me try in the global spanning tree, VLAN, default VLAN, VLAN 1. Okay, and here I'll change the priority. And let's say priority, I'll set it something else. Okay, so it has to be in the increment of 4096 only. So let's say I'll set it 4096 only. Okay, now what will happen? Switch 1 will receive a superior BPDU. And you see here, root guard block. Root guard blocking port Z0/0 on the VLAN 1. Okay, it is blocking the port Z0/0 on the VLAN 1. Why? Because on this particular port, a superior BPDU has been received. And if I check do show interface status, interface status is connected. Okay, show spanning tree. Do you see both the ports they are blocking? And the problem is what? Route inconsistent. This is route inconsistent. Okay, and as soon as switch 2 will stop sending the, okay, as soon as switch 2 will stop sending the superior BPDUs, after that they will come up again. Wait for it.
15 seconds, right, sir? 15 seconds, right?
Which one?
For that switch to come out from the block state
Yes,
to listening state.
correct. So it will wait for the BPDU, right? See
Right.
here, from blocking to back again. Root guard unblocking the port. Okay, so now it is in the learning state. Then it will go to the forwarding state. Now both are forwarding. Clear? Yes or no?
Sir, blocking means fully down, right?
Yeah, down. The interface is down.
Okay.
That means it will not allow anybody else to have communication.
Only forwarding state, the switch port
Yeah.
will communicate.
Correct.
Okay, sir. Thank you.
Now, let me open those. So we have seen about these things we have to see. Root bridge modified STP path cost. STP protection mechanisms. Yeah. Root guard we have seen. Port first we have seen. BPDU guard we have seen. BPDU filter we have seen. Now problem with the unidirectional links. Okay, now what is a unidirectional link? Okay, so if we talk about a unidirectional link, when this kind of condition arises, everybody is aware about fiber optic cables, right?
Yes, sir.
So network devices that uses fiber optic cables for connectivity, they can encounter the unidirectional traffic flow. When? If one of the strand is broken. Now in optical fiber cables, what do we have? We have one separate cable for transmission and separate cable for receiving the data, right? So if one of the strand is broken, in that case, what is going to happen? The communication will become unidirectional. Okay. So see here. Say this is one node, this is second node, and they are connected using an optical fiber cable. So in the optical fiber, there will be one cable for transmission, one cable for receiving. That means not cables, but strands will be there. Okay. So let's say this is for transmission. This is for receiving the information. Here, this one is receiving the information and this one is transmitting the information. Okay. Now, so if you see here, if one of the strand is broken, let's say if this particular strand is not working, this one is not working. So what will happen? The communication will become unidirectional because using this strand, the communication was going from here to here, and using this strand, the communication was taking place here to here. But since this strand is broken, so now this communication got affected and the communication became unidirectional. Okay. So what will happen? BPDUs will not be able to transmit, causing other switch on the network eventually time out the existing route port and change the port, resulting in a forwarding loop. Okay. So what will happen now? Let's say this particular switch will not receive. This particular switch will not receive the BPDUs from here. Okay. So it will consider that, okay, this guy is down, and it will try to change the STP topology, and which might lead to a loop. So to avoid these kind of loops, we have two solutions. Number one is UDLD and number two is STP loop guard. Okay, this STP guard is what? STP loop guard. Okay, so first we will understand about the loop guard. Now this practically showing this will not be possible because in EVNG you cannot have fiber optic cables. Okay. But I'll try to show you the loop guard using Ethernet cable only. Okay, we will have to just make some modifications, but that will do. Okay, and UDLD we will just understand theoretically. Clear? So STP loop guard. The STP loop guard prevents any alternative port or route ports from becoming designated port due to the loss of BPDUs on the route port. Okay. So what we will do is we are going to configure the loop guard on the alternating ports, and the loop guard will place the original port into error disable state while the BPDUs are not being received and transitions back to the STP state where it began receiving the BPDUs again. Okay, so here it might look a bit confusing, right? Overall, you need to understand is that this loop guard will prevent your alternating port or route port from becoming a designated. That means on whatever the switch you configure, whatever the switch you configure this loop guard, right? That switch will not have a designated port. Your blocking port will not turn into designated port. This is what we are trying to say here. Okay. So if you want to enable it globally, spanning tree loop guard default. If you want to configure per interface, then you can say spanning tree guard loop. Okay. And you can use the command show spanning tree inconsistent ports, where this is going to show you the ports in the inconsistent state due to the port not receiving the BPDUs. Okay, that means the inconsistent port statuses we can look here. So now, like I said, practically this will not be possible, but see, I'll try to create a scenario here. We will try to intentionally make a unidirectional link. So how we are going to do it? consider these two switches, switch 4 and switch 5. Let me connect one more cable here. Okay. I'll wipe these. Now, switch 4 will become the root bridge here. Okay. So here what is going to happen? This will be the root bridge. And this will be the non-root bridge. Okay. So because this is the root bridge, this will be designated port. This will also be designated port. Okay. This port, this will become root port. This will become alternating port or the blocking port. Okay. So what I'm going to do here on this port, the alternating port right here. Here I'm going to configure what? Loop guard. Because this is the alternating port. Here I'll configure the loop guard. Now to make it as a unidirectional link, what I need is that I should not send BPDUs this side. So to prevent sending BPDUs, what I'm going to do in here on this port, I'll enable BPDU filter. Okay, I'll enable what? BPDU filter. And this will do what? This will make this switch also as a, this will try to make this switch also as a root bridge. Okay, and that might try to cause a loop. So in this case, when you will try to see the output, the switches might not respond. Okay, so we may have the thing that, okay, the switches will not respond. Okay, so let's try to see the practical. Switch 4, switch 5. So first, let's go and check on the switch 4. Enable configuration terminal, host name, switch 4. And here, okay, this is switch 4 only. On the switch 5, host name, switch 5. All right. So here what I'll do is, if I check show spanning tree, again the ports I have to close. Switch 4, switch 5. Okay. So these ports I already shut down now. Now check. Show spanning tree. Both are designated, and you can see this is the root bridge. And here, show spanning tree. You can see Z0 by 0 is the root port and 0 by 1 is the alternating port. Okay. Now what I'll do is on the alternating port, I'll enable the loop guard. Okay. So go to the global configuration mode and say interface Z0 by 1 spanning tree. And if you check here, guard loop, guard And you can see we have an option for loop. So I have enabled the loop guard here. And now I need to create a unidirectional link. So to create a unidirectional link on the Z 0x0 interface, I'll enable what? BPDU filter. Interface V 0x0, spanning tree, BPDU filter, enable. Okay, so now we should be able to see the logs. This will take some time, like I said. Immediately the logs will not pop up. And if I check do show spanning tree, do you see? This is trying to make it as a root port. It is in the listening state. Learning state. Forwarding state. See, now this particular switch is misbehaving. See, not even functioning. This is not even functioning. Why? Because it is trying to create a loop here. Okay. And because of that, you see here we got a log. This is not the log we are looking for, but here you see the UDLD process is consuming a lot of CPU. And UDLD stands for unidirectional link detection. So we will be able to see the log also. Just need to wait. See, both the switches not responding. Wait for it. When it will start responding, then we will be able to see the logs. Right now, both the switches CPU is very high. And the switches are not responding at all. Mhm. The switches are not responding. Mhm. Same side, this switch also you can see the UDLD is consuming a lot of CPU. Mhm. Mhm. They won't respond now. So this will be actually better to see with the fiber optic cable only. Okay. Like I said, sometimes we will be able to see, sometimes we will not be able to see here because the switches won't respond. And you can see the continuously UDLD protocol. So let me do one thing. I'll try to stop one switch. Okay. See, now it started responding. And now you can see, we get the logs also. Okay. That loop guard blocking the port. Which one? Z0 by 1 on the VLAN 1. Now if I check do show spanning tree, so you can see this is in the blocking state and the reason is loop inconsistent. Okay. Do show interface status. So here it will show you connected. Hope you now you're able to see the loop guard in action. Okay. So now it is unblocking the port. Why? Because I have restarted this switch. So the BPDU filter configuration has been removed. Clear? Guys, clear, right?
Yes. Sir, without saving, you restarted the switch, right?
Sorry?
Restart the switch without saving, right?
Yeah. I restarted the switch without saving.
Okay.
That's why the BPDU filter configuration is gone and the port has been unblocked.
Yes.
And that is the reason the switches are responding. If I just go and enable it again, see here, they will stop responding again. Interface gig 0/0, spanning tree, BPDU filter, enable. Now check again. Okay. Do show spanning tree interface 305. Okay, now you see it is trying to, here loop guard is enabled and it is now in the listening state. So again, it will stop responding in some time because there will be a loop. As soon as this will come in the forwarding state, there will be a loop. Okay, and since there will be a loop, these switches will stop responding. Now they are in the forwarding. And now you will see that they will stop responding in some time. Do show interface status. As the traffic will grow up, Okay. So loop guard will block it again. Spanning tree interface 0 by 1. Detail. So loop guard is enabled here. Interface gig 0 slash. Interface 0 by 1. No spanning tree. Guard loop. Shutdown. No shutdown. Okay. So this is just a trick to see, right? This is just a trick to see whether things are working or not. Otherwise, this particular concept and UDLD both are for fiber optic cables. Listening, learning, and forwarding. So now again, we are not able to see the log for the loop guard. But earlier you have seen, right? The same concept is going to remain. This is clear about the loop guard. So this is a concept of the fiber optic, where if one of the strand is broken, your communication will become unidirectional. And due to the unidirectional communication, what will happen? There can be a forwarding loop, and to avoid that forwarding loop, loop guard will put the port in the loop inconsistent state. Okay, and we can use the command show spanning tree inconsistent ports, and this will show you the inconsistent ports. Okay, but right now we will not be able to see because here there are no ports inconsistent. So let me just do one thing. Okay, this switch is not responding. Switch 5 is responding. I have to restart the switch. Start it. So in here, we can use the command. Okay, now you see, we are able to see the log again, and we can see show spanning tree inconsistent ports. Okay, so you can see inside the VLAN 1, gigabit 0/1 is loop inconsistent. Okay, this is clear. Yes or no?
Yes, sir.
Okay. Then we have the UDLD concept. So UDLD, unidirectional link detection, allows for bidirectional monitoring of fiber optic cables. So UDLD operates in two modes. One is the normal mode and another one is the aggressive mode. So in the normal mode, what happens if a frame is not acknowledged, then the link is considered undetermined and the port remains active. That means the state of the link will be remaining inconsistent and the port will still remain active. That means the port will not be put to the error disable state. While in aggressive, what happens? That if a frame is not acknowledged, then the switch will send another 8 packets in 1 second interval. That means one packet, then 1 second wait, then again one packet, like this, after 1 second interval, it will send 8 packets. That means 1 frame, then wait for 1 second, again 1 frame, again wait for 1 second, again 1 frame. If those packets are also not acknowledged, then the port will place into the error state. Okay, this will what will happen in the aggressive mode. Okay, now the configuration is up to us. Okay, so to enable the UDLD, we will say UDLD enable, and by default it will enable the normal mode only. If you want to enable aggressive mode, then you will use the aggressive keyword. Same way UDLD port. Okay, this will command UDLD on the interface and UDLD aggressive. Okay, so if you want to enable the aggressive mode, to disable it, this is the command. For recovery, let's say the port has been put to the error state, so we can use the recovery, UDLD recovery, and the time. Okay, the default value is 5 seconds. If you want to display the neighbors, so you can say show UDLD neighbors. Okay, and again, if you want to check the interface details, you can say show UDLD interface ID. Okay, now this thing practically I'll not be able to show you, but I can try to show you the neighbors. Show UDLD neighbors. Okay, right now nothing is here because we don't have the fiber optic cables. Host name switch 4. Okay, so let's try to enable it. UDLD enable, this side enabled. Here also I'll enable it. UDLD enable. Now we should see the neighbors. Okay, do show UDLD neighbors. Nothing. Do show UDLD neighbors. And sometimes this will also happen that you will not get output in the global configuration mode, but you will see the output in the privilege mode. Okay, here both the cases are same, so it doesn't make a difference. Okay, so this is how these are the commands we can use. Then after this is it about the UDLD. So about UDLD, like I said, we will not be able to see the practical because here we require the fiber optic. Okay. Then after this, we have to talk about how you can manipulate, okay, the root bridge. So we can manipulate the root bridge by...
Sir, what is unidirectional and bidirectional?
Unidirectional means communication in a single direction. Bidirectional means two-way communication.
In case of ICMP, there are ICMP echo and ICMP reply also there. That is bidirectional.
Which one?
ICMP. Echo
So
request
all
and
communications are bidirectional.
ICMP echo request and ICMP echo reply.
Yeah,
that is bidirectional, no?
Yes, this is bidirectional.
Okay, okay. And unidirectional example?
Unidirectional communication. Let's say if here in this case, right now, if you want to understand unidirectional, so just say I have one switch, I have another switch. And if you connect a fiber optic cable, right? So now we know that one cable has a TX ring and RX ring. That means transmission and receiving. And this is RX, this is TX, right? So This one is used to send the data. This one is used to receive the data. Now, if one of the strand of the cable is broken, then this will get affected. Only one-way communication. This is unidirectional. Okay.
Okay.
Yeah. It's not about the protocol, it's about the communication due to the cable. Okay.
Okay, sir. Thank
Yeah.
you.
Then we can change the root bridge in our STP topology. We can use the command spanning tree VLAN ID and priority, and we can define the priority also. Okay. So just now I did it right when we were practicing about the root guard. So again, we will do the practical here. Go to the switch one. Enable. So spanning tree. So you can see as of now, switch one is the root bridge here. We are talking about this topology, okay? So what is happening here? Switch one is the root bridge. Switch two is the non-root bridge. Switch three is also the non-root bridge. Okay, now what I want that, okay, switch two should be the root bridge in the VLAN one. So I can go on switch two and I can say enable. Okay, let me check first of all, root guard is enabled. Do show spanning tree interface gig 0/0 detail. Yes, root guard is enabled. I need to disable it. Interface range 0/021. No spanning tree guard. Okay, root guard has been disabled. Now I can do it. So check here. If I say do show spanning tree, show spanning tree. So right now, switch one is the root bridge. Now I want that, okay, switch two should be the root bridge. So I'll go in the switch two and I'll change the priority. So first, if I check do show spanning tree, so I can see that, okay, initially the priority between the root bridge and the switch two was equal, but the MAC address of the root bridge is less right now. That's why this guy became a root bridge. So what I'll do here, I'll change the priority. I'll say spanning tree VLAN 1. Okay. And I'll give the priority, and let's say I'll change the priority to 4096. Okay. Now I change the priority. So what will happen? This guy will get less priority now. And since this guy has a less priority, you see, this bridge is the root, having the MAC address 0002. And even earlier switch one was saying that I am the root bridge. And now switch one will say, no, I am not the root bridge because my priority is this much and the root bridge priority is this much. This is one way we can manipulate. Clear? Guys, clear, right?
Yes, sir.
Okay. Another
Sir,
way is, yes.
Sir, that range start with 32769. To
That is the default. 32768 is the default. Okay. And if you want to take a look at the range, so it is from 0 to a large number, 61,440. And it has to be a multiple of 4096, like 04096, then 8192, like that. Clear?
okay.
Yeah. So this is one way. Now I'll say no, and it will get the default priority. And again, switch one will become the root bridge. Okay, again, the election will take place and switch one will become the root bridge. Wait for it. Okay, you can see root bridge has changed. Earlier this was saying that, okay, this bridge is the root, and now it says that root bridge is connected on this port. MAC address 0001. Right? Now, another way is we can use the command spanning tree, VLAN ID, root, and we can use the keyword primary and secondary. Okay, maybe you do not want to manually define the priority. Okay, so what you can do, you can use the keyword primary and secondary. So the primary and secondary keyword will do what? They will change the priority. Okay, so the primary keyword, see, what is the default priority? Default priority is 32768. This is the default, right? And if you use the keyword primary, okay, so it will subtract 8192 from this. Okay, and if you use the secondary keyword, it will subtract 4096 from the default priority. Okay, so when you use primary, so it will be 32768 minus 8192, which will be 24576. This will be your new priority if you use the primary keyword. And if you use the secondary keyword, it will be this minus 4096, which is 287672. Okay, so automatically this will be having the least priority. So this will become the root bridge, and this will become the secondary root bridge. That means in case your primary root bridge goes down, then another switch will be there who will become the root bridge. So this kind of scenario you use when you want that, okay, only specific switches should be the root bridge. Any random switch in the network should not become the root bridge. Okay, any random switch with a lower MAC address should not become the root bridge in those cases. This is clear? Yes or no?
Yes, sir.
Sir,
Yes. So now let's go and check it. So again, you can see switch one is the root bridge. So here I can say spanning tree, VLAN one, root, primary. So if you now check the priority here, the priority will be 24572, sorry, 576. And if I go on the switch 3 and if I say enable configure terminal, spanning tree, VLAN 1, root, secondary. And if I check, you can see 28672 is the priority. And here the priority is 24576. And for switch 1, the priority is what? 32769. So as of now, you can see that switch 2 will be the root bridge with the MAC address 02. And if switch 2 is not becoming the root bridge, let's say here I'll remove this primary. So when your primary is not available, in that case, your secondary will become the root bridge. Take a look. In some time, this switch 3 will say that I am the root bridge. Wait for it. Now you can see. Switch 3 says I am the root bridge, and even switch 1 and switch 2 will say the same thing. You can see switch 3 is the root bridge. Clear? Yes or no?
Yes, sir.
All right. So this is another way we can change the root bridge. And if I will say no, again, switch 1 will become the root bridge. So this is one about the root bridge placement, that your root bridge has to be at the lowest value and the secondary root bridge to have value that is slightly higher than the root bridge. Okay, and all the other switches, they will have a value higher than secondary and primary. Okay. Then we can modify the root port and block port also. Okay, so for that reason, we have different concept. One is the port cost. Okay. Number one is the port cost. And then we can use the STP port priority. Okay, so these two things we have to see about the port cost and port priority. First of all, let's talk about the port cost. Assume this topology. Okay, so if we take a look at this topology, we have seen that, how the calculations are here. That this port will be alternating port, this port will be designated port. Okay, so how this cost is calculated is, let's say for example, this root bridge, when this guy will advertise the cost, so root bridge will say that from my port, the root bridge cost is 0. That means distance to the root bridge is 0. Then this guy will say that, okay, my cost is what? 4. On this port, on the root port, this is a gigabit port, so my cost is 4. So it will add, so 0 plus 4 will be 4. Okay, and then this 4 will be advertised here, and this guy will have a cost of how much? This 4 and plus this 4, total 8, right? Yes or no? This is how the cost is. Getting it? Okay, then same thing will happen on the other side also. From here, when the cost will be advertised, okay, so this cost will be advertised 0, because root bridge itself is the root bridge only, right? So from there is no cost. And this guy, switch 2 will add its own cost, that is 4. And when switch 2 will advertise the cost, so this side when switch 2 will advertise, it will advertise 4. And this port will add its own cost, 4. That is total cost 8, right? Yes or no? Correct. Remember when we were talking about, how the switch 2 and switch 3 will calculate this designated port. So first of all, what they will check? They will check the cost only. They will check the cost only. And we were getting that, okay, when this guy is going via this path, so 4 plus 4 is 8. Okay, and when the switch 3 is going via this path, this is also 8. Then this switch 2 had a lower MAC address. That's why this became designated and this became alternating port. Right? So
Yes, sir.
what will happen? When they will check, right? Let's say, for example, once the cost is reduced. So this guy, let's say I'll change the cost here 1. And here I'll leave it default, which is 4. Okay. Now when we will check the cost, so out of switch 2 and switch 3, who has the lower cost?
Switch 3.
Switch 3. So switch 3's port will become the designated port. Okay. So let's see here. So all I have to do is I'll just go and change the cost. Okay, so I'll just go on the switch 3 and change the cost of this port to 1. Okay. And if you want to change the cost, the command is spanning tree, VLAN ID, cost, and the cost. Okay, take a look. On the switch 2, right now if I see, so my Z0 by 1, this interface is the designated port. And on the switch 3, if we check right now, Wait a minute. This is root port. This is designated port. This is root port. Okay. Yes. Switch 3 interface Z0/0, you can see. What is the state here? Blocking. So as of now, what we are saying is that this is alternating port. Okay, the color I need to change. Okay, so this one is the alternating port, and this one is the designated port. So we will change this thing, right? And see how we will change. So I'll go on this interface Z0/1 of the switch 3 and I will change the cost. So configure terminal, interface Z0/1 on the switch 3, spanning tree, VLAN 1, cost, and you can see cost value I can give from 1 to this large value. Okay, so I'll give it 1 only. When I'll give the cost value 1, now see what will be the change. Earlier my Z0/0 was alternating and Z0/1 was root. Now let's see. Do you see 0/0? What it became? Designated, listening, learning, and forwarding. Learning, still learning, forwarding. So you see now the Z0/0 interface of switch 3 became the designated port. This port became designated, this became alternating. See here. Earlier, the Z0/1 port of the switch 2, designated port. And now this is the alternating port. Is it clear?
Yes.
Okay, so we can alter the, alternating ports and all. Clear, right? Clear to everyone? I
Yes,
just
sir.
changed the cost. So this guy had a lower cost and became the designated port here. Okay. Now, let's go and set it back to default. Then another concept is there, which is about the port priority. Okay, so port priority is used whenever you have more than one link, whenever you have redundant links, or more than one link between the two switches. So for this concept, we will use this lab switch 4 and switch 5. Okay, and I hope everything is default here. Do show. Let me verify. Show running interface 0/0. Nothing, 0/1. Okay, here loop guard is there. So I'll remove the loop guard. Interface Z0/1. Okay, so from here I have removed the loop guard. Let me check any configuration on switch 4. Enable configuration. Interface Z0/0. Nothing. 0/1. Nothing. Okay, now this is the default configuration. So if you check do show spanning tree. Okay, so many ports. Let's check. Do show spanning tree. Okay, so I can see that here both the ports are designated port. And on switch 5, if I check show spanning tree, so 0/0 is the root port and this is the alternating port. So here this is the DP. This is also designated port. This is root port. This is alternating port. Okay, this is the scenario right now. So what I'll do is I want that, okay, Z0/1 should not be the alternating port. It should be Z0/0. Okay. Z0/1 should not be blocked. Z0/0 should be blocked. Okay, this is my condition that, okay, I have more than one links, but out of these links, maybe Z0/0 is the faster link. So this is the one that I want to, like Z0/1 is the faster link. And because of STP, this is getting blocked. Okay, so maybe I want this link to be up and this link to be down. Okay, so how do I do that? So what I'll do, I'll give more priority to this. Okay, I'll give more priority to this interface. How? See here. STP will always check for the lower priority, right? So here, if I check what is the priority of this interface, second interface, 128, and on switch 4 also, you can see Z0/1 is 128. So on this root bridge, I will say that I want to give more priority to this link. Okay, so what I'll do is I'll go to the switch 4 interface Z0/1. Okay, and I'll say spanning tree, port priority, and my port priority value can be between 0 to 240, and it has to be a multiple of 16. So let's say I'll make it 64. Now, if I check do show spanning tree, so you will see that now this has a priority of 64. So this will be given high priority. Z0/1 will be given high priority or preference, and this link will never be blocked. So you will see here. Now 0/0 is in the alternating state and 0/1 is in the root port. So it's learning state and it will be forwarding in some time. Okay, you can see. So this is how we can manipulate using port priority. So if you have more than one links between the switches, you will use port priority. And if you are to change between multiple switches, okay, in that case, you can use the STP coast. Clear? Yes or no?
Yes, sir.
All right. Then let's also discuss one last thing before our STP. So root guard, port fast, BPDU guard, filter, loop guard, unidirectional link. This all we discussed. Root port and root bridge. Okay. These things are discussed, and from here we have a little bit of discussion. Yeah. So STP topology changes. That means those direct link failures, indirect link failures, those are the conditions we need to discuss. So first of all, there are few points that we need to understand. Okay. What are the points? That BPDUs always flow from the root bridge towards the edge switches. Okay. Because see here, try to understand this thing. BPDUs will always flow in this direction. Why? Because this guy is having higher preference. This guy's BPDU are superior. So when these guys will send BPDUs, so they will have a lower priority or lower MAC address. So this switch will discard their BPDUs. This switch will discard their BPDUs. So BPDUs will always flow from the root bridge towards the edge switches. Okay. Then any switch that detects a link status change is going to send a TCN BPDU towards the root bridge out its root port. That means in the network, if there is any problem, so these guys, non-root bridges, okay, they will send a TCN BPDU towards the root bridge. But TCN BPDU can be sent through the root port only. TCN BPDU will be sent through the root port only. So this guy will send through this port and the switch 3 will send through this port. Okay. Now, if an upstream switch receives a TCN, it will send out an acknowledgement and forward the TCN out its root port to the root bridge. That means in between, if any other switch is there, so let's say, for example, here there is one more switch. Here there is one more switch. So what will happen when this guy will send a BPDU, TC and BPDU? So this switch will send an acknowledgement back. Okay, let's say switch 2 is sending a BPDU to this TC and BPDU to this. So this guy will do what? This guy will send an acknowledgement to the switch 2. And then this switch will send a BPDU, TC and BPDU to the root bridge. Okay, that means his task was to send the TC and BPDU here. Then this switch will send an acknowledgement, and this guy will generate a TC and BPDU for the root bridge. This is how the TC and BPDU travels. Clear? Yes or no?
Yes, sir.
Okay.
Ajay sir,
Yes.
yeah, one doubt. Correct me, sir, if I'm wrong.
Mhm.
So, okay, in real time, assume that I have the same three switches,
Mhm.
and okay, now your switch one is the root bridge, and the other two bridges,
Mhm.
other two switches are non-root
Correct.
bridges.
Mhm.
Okay, the connection that you have shown here, so that is assuming it is a 1 gigabyte link, right?
Mhm.
So
Correct.
that is why the distance is 4. That is, you are using the short mode, which is the default mode, and you
Yes.
also have a long mode. Okay, this is clear. That connection, when I'm saying from switch 1 to switch 2 or from switch 2 to switch 3, this is nothing but the uplink, right?
Mhm. The switch
Right?
1 to switch 2 and switch 3 to switch 1. This is
Yeah,
up. Mhm.
uplink, and that port will also be a trunk port, right?
Correct.
Otherwise, the communication will not happen.
Mhm.
And that election also happens in the trunk port only, right? The root port, your designated
Yes.
port, your
Mhm.
yeah. But in real time, no, sir. But we will be having minimum 2 uplinks for each switches, right?
Yes.
So in that case, that will be a backup port, right?
Mhm.
So that time will the switch will not get confused and will not get into that election mode, continuous election mode, and get into a looping.
No, because if more than one link is there, again, STP is going to block one of the link. If this is the case, let's say if you have more than one link, redundant links are there. In that case, STP will block.
Okay.
Okay.
But if the so here you what you are telling, like, sir, you are saying that primary and secondary, can we still define it?
Yes, we can define it.
Okay. So in that case,
That won't change anything. STP will make sure that you have one loop-free path to all the switches.
right. Okay.
Yeah. Okay. So
Okay.
from root bridge to all the switches, you will have a loop-free path.
Okay. Okay.
Okay. All right. So upon receiving the TCN, the root bridge is going to create a new configuration BPDU with that topology change flag set. And then what will happen? It is flooded to all the switches. So once, once the root bridge receives a TCN BPDU, let's say this is the TCN BPDU. So what the root bridge is going to do? The root bridge is going to generate a configuration BPDU, a normal BPDU, but in that BPDU, it will set the flag topology change flag it will set, and that will be flooded to the switches. This is how everybody is made aware about the changes. Okay. So whenever a switch notice any change, it will generate a TCN. And if there is any switch in between, it will send an acknowledgement. And then this switch will generate the TCN for the root bridge. When root bridge receives a TCN, root bridge will do what? Root bridge will generate a normal configuration BPDU. In that configuration BPDU, it will set the flag about topology change. Okay. And this is how everybody will come to know about the topology change, that there has been some changes in the STP topology. Okay. Then When the switch receives this, they may set their MAC address timer to default 15 seconds. That means by default, we know that, okay, MAC address stable time is what? 300 seconds, but they will change it to 15 seconds. And then the device will flush its CAM table if it has not heard from a device in the last 15 seconds. Okay, so after 15 seconds, they will flush the CAM table. Okay. TCNs are generated on the VLAN basis. So the impact of TCN directly correlates to the number of hosts in the VLAN, that how many TCNs will be there. Okay, so TCNs are generated on the VLAN basis, and impact of TCN directly correlate to the number of hosts. Okay, now by keeping these points in mind, okay, now we will understand about the direct link failure. So consider this topology here. Okay, that we have switch 1, switch 2, switch 3. Okay, and this is the similar topology that we are having right now. Okay, this is the one that we have been discussing, that we have designated, alternating, designated root ports, and this guy is the root bridge. Same topology is there. Okay, now we are considering that, okay, this link here goes down, this link is down. So if this link is down, what will happen? See here, link failure between switch 1 and switch 3. So when this link will fail, only 2 switches can detect it, switch 1 and switch 3. Switch 1 is the root bridge, so this guy cannot generate a TCN. Who will generate a TCN? TCN will be generated by the switch 3. So switch 3 needs to send a TCN, but the problem is TCN can be sent out only root ports. So this is the root port, and it will try to send us TCN this side, but this link is blocked. So what will happen? This guy cannot send a TCN. Okay, so what the root bridge will do? Root bridge will set what? The configuration change in the topology change in the configuration BPDU, and it will send a configuration BPDU this side. Okay, it cannot send a TCN, right? A TCN BPDU it cannot send, but it will send a configuration BPDU. So it will send it this side. Then what will happen? This guy will receive it, switch 2 and switch 3. So like I said, if a BPDU is there, they will forward it to everybody. So when switch 2 will try to forward it this side, the same BPDU when switch 2 will try to forward it this side, this port is blocked. So again, this BPDU cannot reach here. That means switch 3 has no way to update, right? That, okay, there has been some changes. So what will happen? Switch 2 and switch 3 receive the TCN and change the MAC address table age time to forward the delay time. Okay, so that means your CAM table time, MAC address table time will be changed to what? 15 seconds. And after 15 seconds, what will happen? This guy is going to flush it. Okay, so first thing is your switch 3, okay, is going to wait for the max age timer before it can restart the STP process. Before restarting the STP process, this will wait for max age timer. Then after, this port will go to the listening and learning state from blocking. So 15 seconds for listening, 15 seconds for learning. And then the BPDU is sent every 2 seconds. So when this BPDU will come after 2 seconds, okay, then this switch 3 will be able to update all the changes. So overall time, if you see, 20 seconds is the max age timer that the switch 3 will wait, 15 seconds for the listening state, 15 seconds for the learning state, and then 2 seconds it will wait for the BPDU. That means every 2 seconds the BPDU is generated. So the network will converge again back to its normal condition after how much time? 52 seconds. Understood? Yes or no? Correct. Okay. So only thing you have to take care is that how the BPDUs will travel. That's it. That here there was a link failure and only these 2 switches could detect it. So this guy cannot send a TCN because the link is down, and switch 1 cannot send a TCN because it is the root bridge. Okay, so switch 1 will send what? Configuration BPDU with the topology change set to the switch 2. Switch 2 will send it to switch 3, but this is blocked. Okay, so switch 3 will do what? when it will not receive BPDU from any side, what it will do? It is going to wait for the max's timer. Okay. Once max's timer is gone, 20 seconds. After that, it will change this port to listening and learning. Okay. And once it has changed to listening and learning, then after 2 seconds, BPDU will arrive. And you can see in 52 seconds, your network will be up and running again. Okay. So this is one scenario where we have direct link failure. Now, next scenario. Okay, this is the same. This is indirect link. This is also direct link failure. This is also direct link failure. Only difference is that earlier it was on the switch 3 side, and switch 3 was not having any possible way to send the BPDU, TCN BPDU. But what if the failure is here? Okay, what if the failure is here in this place? So let's see what happens. So this time, this link has failed. Again, this link has failed. Only 2 people can see that, okay, whether or not only 2 people can know about it. That is switch 1 and switch 2. Again, switch 1 is the root bridge, so it will not send the TCN, and switch 2 has to send the TCN, but its root port is down. Okay. So then what will happen? The switch 2 will advertise a configuration BPDU where it is the root bridge. So as soon as the root port is down, switch 2 will advertise the TCN, configuration BPDU, saying that, okay, I am the root bridge. But when this will send the information here, what will happen? Switch 3 will flush the CAN table and MAC address table and discard the switch 2's BPDU. Why? This link is blocked. This link is blocked. And when this guy generated a configuration BPDU, at the same time, this original root bridge also generated the configuration BPDU. Okay. So this is more superior. This has been discarded, and also this will not accept as this link is blocked. Then what will happen? The STP max's timer will expire on the switch 3, and it will move the Z102 to the listening port. This port, it will change to listening and then learning, and then it will advertise switch 1 BPDU to switch 2. Then what will happen? Switch 2 will receive the switch 1 BPDU and make Z103 as a root port and changes to the port listening state. That means again listening, learning, forwarding. So again here also the time will be what? 52 seconds only. Okay, this is a similar condition. Okay, understood? Yes or no?
So the switch 2 will be in the same state, like it will learn forward block. That is only happening, or it will not directly.
Sorry.
Okay. So if switch 3 is blocking the PPTU configuration, the switch 2 will be root port, or it will only
this one will become root port, right? Because for this switch 2, this will be the shortest path to the root bridge. So this port will become the root port. Right now, this is designated port. But once switch 2 will receive the BPDU of switch 1 from the switch 3, so this will change it to the root port. See here, switch 2 will receive the switch 1 BPDU and make the G103 as a root port and changes the port to the listening state. So then listening, learning, and forwarding.
Okay.
Okay.
So, but designated port are always in the forwarding state only,
Yeah,
right?
this is in the forwarding state, but here this will be blocked, right? This side switch 3 port is blocked.
Okay.
That is the reason. Okay. Now, what if there is an indirect link failure? Now, indirect link failure simply means, see, direct link failures, we understood that the entire link itself is down. But sometimes, there can be situations when the link is up, link status is connected, only the communication has been affected. Maybe, the packets got corrupted or something. Okay. So STP communication between switches is impaired or filtered while the network link remains up. The link is up, but only the communication is impaired or the filtered. So in this case, what will happen? This situation is known as the indirect link failure, and the timers are required to detect and remediate the topology. Okay. So again, we are considering here that, okay, the data is impaired. That means this time the link is not down, only the communication is not happening. So what will happen? The switch 3 will wait for the MACsys timer 20 seconds before it can move the Z102 to the listening state. That means before opening this port, this switch will wait for 20 seconds. If still there is no, you can say if still there is no BPD received from this side, then what will happen? Switch 2 will continue to advertise switch 1 BPDU. So from this side, BPDU is not coming from, but from this side, configuration BPDUs are coming, right? So the switch 2 is going to advertise the switch 1's BPDU to the switch 3. And then switch 3 will mark Z102 as the root port and continue with the listening and learning state. So here it will be completely use of timers only. Here only the use of timers is there. That here communication got impaired. So this switch will try to, wait for 20 seconds before bringing this port into the listening state. But meanwhile, the switch 1 has sent to switch 2 and switch 2 is forwarding the BPDUs to switch 3. And once 20 seconds expire, then the switch 3 will do what? This will put this port as a root port and it will start listening, learning, and forwarding state. Okay. Is it clear? Yes or no?
Yes, sir.
Only the timers, MACsys timer, listening, learning, that's it. And 2 seconds for the BPDU. So this is about indirect link failures. And this is the indirect link failure. Then RSTP. So RSTP we will start tomorrow. Okay. Tomorrow we will complete RSTP and MST. Any doubts so far?
Sir, STP is automatic configuration, automatic, right?
Yeah,
And
by default
RSTP
it is there. We can manipulate some parameters, like we can decide which port will be the blocking port, which port will be the non-blocking port, or forwarding port.
So for configuring the RSTP, we need to disable STP, right?
Yeah, we just need to change the mode. No need to disable, but we just need to change the mode.
MSTP as well.
Yeah, MSTP as well.
Okay. Okay. Thank you.
So tomorrow you will know about these things.
Okay.
Okay.
Can we change any port into
Yes.
block state or
Any
can we
port.
change any block port or alternating port?
Sorry, your voice is not clear. I'm not able to hear you clearly. Can you repeat this?
Can we change any port into block port or alternating port?
Guys, if anybody is able to hear, please tell me. Can you please type it in the chat? Drop your question in the chat, please. Can we change any port into blocking port? We can decide that which port will not be blocked, okay, by using port priority. And yes, we can decide that which port will be blocked, but that will require modification of the root bridge, that will require modification of coast and port priority. Okay. Yeah. Okay, guys, then tomorrow we'll start with the RSTP and MST. Okay. See you guys tomorrow then. Have a good day.
Thank
Thank
you.
you, sir. Thank you, sir.
Okay,
Thank you, sir.
okay guys, thank you.